Hi, I'm Andrew Balmos, data and software engineer for Purdue's College of Agriculture. And today I want to talk about some of the connectivity projects that we have ongoing at the farms. The first one I want to talk about is IsoBlue Wi-Fi test. Here we were trying to build a machine-to-machine Wi-Fi network that would essentially enable automated or assisted coordination between vehicles during harvest. And we wanted to do it with just simple, inexpensive, off-the-shelf radios, so we picked Wi-Fi. We built the system by taking the Ode Center's IsoBlue box, which is really just an open source telematics device. And you plug it into your machine and it would stream position and machine data up to the cloud over the cellular network. We took it, we put it in a new enclosure. It was a little bit bigger, increased the CPU, the computing power of the processor inside it a little bit, and then attached this inexpensive Ubiquiti Wi-Fi device to it. We built 5 of them. We installed one onto each of the 2 semis at ASREC, one to their combine and one onto their grain cart. And then we wrote a program that would just do simple speed tests between vehicles as they drove around. Since we had the GPS position from IsoBlue and the speed test data, we could build maps and statistics on how good of a link did we have when they were certain ranges apart from each other or certain angles with each other. And from that, we could tell whether the Wi-Fi would be a good or poor choice for machine-to-machine networking. We did this test in 2019 at ASREC, and we did it twice in 2020, one early this year at Wheat Harvest and one that's just wrapping up right now. And when we look at some of the early data, we can kind of conclude that Wi-Fi actually makes a pretty good machine-to-machine network for harvest scenarios. If you're in the same field or maybe even neighboring fields, you pretty much always have connectivity between all the vehicles, something at like greater than 90%. And you usually have like tens to hundreds of megabits of speed. It's pretty uniformly distributed over that whole range, but that's easily enough speed to carry machine data and even video streams. So we can imagine all sorts of new types of automated coordination. We could see video cameras in grain carts so the combine operators could see it. The second project that I'd like to share with you revolves around Microsoft's FarmBeats initiatives. And FarmBeats is this tool that takes data from all sorts of places, including the field, and merges them all in Azure to allow you to process them and integrate them together at one time to help develop insights. We're working with Microsoft to do some pilot installations, and one of the places we're doing it is at Professor Jin's gantry at Acre. He has a hyperspectral camera mounted to the gantry that looks down on the field, takes pictures all year long so that he can build these sort of plant models. And our sensors that we're installing via the FarmBeats project will provide some metadata that he needs to help understand what was going on to the plant at the time the pictures were taken. So to see how that was deployed and is being deployed, we can look at our acre and kind of zoom into this area here where we can see the ICSC building where we install the base station. And up here you can just see his gantry where we're installing the sensors. Sensor boxes look something like this. This is basically a computer, a little embedded computer with a big battery pack and a LoRa radio. The embedded computer can talk to a variety of sensors, temperature sensors, soil moisture sensors, light intensity, rain, wind, all sorts of things like that. And they essentially just periodically report their data back to the base station. That base station is called the sub-edge. It's the standard Microsoft upboard with their proprietary software and the Semtech LoRa radio. And these two devices communicate with each other over LoRa using, I'll say, proprietary messages. They're not necessarily super secret, but they are specific to FarmBeats. And this setup works. It's out there deployed now, and we have data flowing to the cloud, but it's not exactly super interoperable. If you have FarmBeats and say another system, sensor system, and they both use LoRa, you probably have to have a sub-edge one for each of the products. And Lorawan, it helps solve that problem. But before I get into Lorawan, I want to mention this guy right here. This is Gangabrit Hondal. He's, I'll say, our FarmBeats mastermind. He's been the one that's put most of the energy in getting these sensor boxes built and configured correctly. He's an RA, a research assistant funded by the WHIN project, and he's been a great help. Lorawan is trying to help solve the interoperability problem of LoRa. It's an open standard developed by a large set of corporations, and their main focus is interoperability and capacity. And so at the test beds, we want to do some public demonstrations of Lorawan to better understand what its application and use cases are. but also provide platforms for other people to use Lorawan either in their research or as their research. And thankfully, Ag-IT is forward thinking, and they've already gone ahead and installed Lorawan gateways on a lot of Purdue properties. At Acre, it's installed on the tower at the weather station, and it essentially can cover the whole area. Covers Acre, covers Azrec, even further than that. Main campus has some gateways, TPAC has some gateways, and some of our other platforms do as well. And so we don't really need to worry about deploying the network side of things. We just need to worry about deploying the sensor side of things. So we've gone ahead and did some work onto the FarmBeats sensor box, converted it to a LoRaWAN radio, and we had to write a little program that did a little command and control with the sensor boxes to ensure that they send the data correctly. And we'll open source that code so that everything is easy to use. And by doing this, we have enabled the ability to just drop these FarmBeats boxes wherever we want. We can even move them throughout the year to collect data, which is really great. And lastly, what we'd like to do is connect these boxes to WHIN's Lorawan network as they begin to deploy that for their weather stations. And really, this is so that we can demonstrate and report on Lorawan interoperability and what are some of the trade-offs and things people have to do to make that work in practice. The last major radio initiative we have going on at Acre is around TV white spaces, both the narrowband and the wideband versions. The narrowband TV white spaces is designed to complement LoRa, long range and low power, but also really low data rates. You need an experimental license to do this right now, and ours was recently granted. Hopefully, the FCC will outright approve this in the near future. We're planning on integrating our TV white space, the narrowband versions at least, into IsoBlue, and then the IsoBlue will operate the same way it does now, except use the narrowband radio rather than the cellular radio. After that, we'll turn our attention to a wideband deployment. Here you're looking at ranges of, say, 5 kilometers with data rates of 10 to hundreds of megabits a second. This is more of a backhauling issue, moving large data from one place to another place. We plan on deploying it on the roof of the ICSC building, and then playing with things like backhauls to Azrec and TPAC. And finally, before I let you go, I want to give you an insight into what we're planning on doing as we move to the latter stages of the grant. One is continuing our knowledge share with WHIN over Lorawan networking. We're both deploying similar hardware and software, and us sharing information is increasing best practices and improving interoperability. When the WHIN aerostat is flying, we'd like to do a CBRS demonstration from machine to CBRS backhaul with using an IsoBlue. We're going to replicate our narrowband TV whitespace demonstration, but using Lorawan to compare and contrast those two technologies, as well as consider other applications in other environments when deploying IoTs. So for example, putting some sensors out at the vet and dairy and considering how animal and livestock needs might change the deployment strategies. So thank you very much, and I'd be happy to take questions in the Q&A session.